In this section, we are going to talk about frequency table. So let's take a look at the definition of frequency table. A frequency table partitions data into classes or intervals of equal width and shows how many data values are in each class. The classes or intervals are constructed so that each data value falls into exactly one class. So looks like we are trying to partition data into classes, right? So what is the concept look like? So let's make it easier. So let's say we are playing Lego. And I have 3,000 pieces of Lego. So these 3,000 pieces are a set of data. Now, I am trying to organize my data. So the way I do this is I have 3,000 pieces for all over the place on my table, right? Just picture this in your mind. You have 3,000 or even 5,000 pieces of Lego for all over on your table. You have different kinds of bricks and wheels and minifigures, so on and so forth, right? So here is how I organize my Legos. I buy a box, I buy a big box, and then inside this box, there are grids, right? There are grids. And then what I am trying to do is I want to categorize all the Lego. So if you have minifigure, so you let the minifigure go to the first grid. If you have a wheel for bus and trucks, you put that on the second grid, and so on and so forth. Like if you have like glasses, the glass windows, something like that, you put that in another grid. So after the job is done, so let's say you are trying to build a truck. So instead of looking through pieces from 3,000 pieces all over the place, you can just pick the piece you want straight from this box. So that means after I organize my stuff, like organize my Lego, I know exactly what to look for. Just like cleaning up your room. You organize all your clothes, so when you go to work in the morning and you want to wear something in specific in that day, you open up your closet and you know exactly where to find the jacket that you want. So that is the concept of using a frequency table. I have a pile of data, maybe 100 numbers, 1,000 numbers. I want to organize this 1,000 or 100 number using a frequency table. So let's take a look at this blank frequency table. There are 6 columns: class, boundaries, midpoint, frequency, relative frequency, and cumulative frequency. So instead of giving you a definition of each column, I will just use a data to show you how to organize this data using this frequency table. So let's take a look at the data description. Commuting distance in the San Francisco Bay Area. The following data is obtained from a survey. Each number represents the number of commuting distance in miles that a person travels to work. A random sample of 60 of these workers was taken. So one means, let's say 1 is me. I travel 1 mile to work. Let's say you are 47. That means you travel 47 miles to work. Let's say my friend is 10. That means my friend travels 10 miles to work. So every numbers represent a commuting distance. And we have a table. So I want to use 6 classes and I want to organize this data using this table. So here is how I'm going to do it. I'm going to start with class, and then to start with class, everything is all blank, right? So that means I have to put something in class. How do we start? First, you have to determine the class width. So the class width, and what you have to do is you use the maximum minus the minimum, the highest value, minus the lower value, divided by the number of classes. So the maximum value is 47, the minimum value is 1, and then you divide it by 6. So you is somewhere around 7.7. So I will round this up to 8. 8 is my class width. What if that is a 7.1 or 7.2? It is reasonable to round this up to 8. We prefer to push the number up, not instead of pushing the value down. So the class width is 8. That means the length of each class is 8 units long. So to build the first class, so number 1, the first class, we need to do 6, right? So we start with the minimum value 1, and then I add 8, and then I will subtract 1. Why do we have to subtract 1? I will tell you why in a minute. So why do we have to subtract 1? It looks like we have 1 plus a equals to 9 and then the job is done, right? Why do we still have to minus 1? Let me explain this after we finish the entire thing. So 1 plus a minus 1 is equals to a. So the first class is 1 to a, right? So the first class is 1 to a. And then second class, you don't start at a, and you start at 9. Why do we start at 9? If you start at a and there is a data, one of the data is a, then there is a double count. Should I put a in the first class or the second class? You don't know. That's why you don't do any overlap. You start at 9. So if you go back to the definition really quick, look at the last couple words. Each data value falls into exactly one class. So one class only, no double count. Right? And then 9 plus 8 minus 1. So that is equals to 16. The second class is 9 to 16. And then the third class, we start at 17. And then we do 17 plus a minus 1. 17 plus a minus 1 is equals to 24. So we have 17 to 24. And then the fourth class, we start at 25 plus a minus 1 equals to 32. So this is a 25 to 32. And then number 5, we start at 33, no overlap, we don't start at 32, plus a minus 1 equals to 40. So the next class is 33 to 40. And then the last class, number 6, we start at 41, and then we plus a minus 1 equals to 48. So the last class is 41 to 48. And then we fill in the table. So this is our class. Now, let me explain how come we have to subtract 1. Take a look at the data. We start at 1, right? So the first class is big enough to cover the 1. And then we end at 48. So the 48 is big enough to fit the highest value, 47. What if I don't subtract 1? If you do not subtract 1, I'm going to do that for you, of course. If you do not subtract 1, that means you accumulate 1 more unit at each class. So 1 plus 8 is equals to 9. So you go from 1 to 9, right? And then 10 plus 8 is equals to 18. So you go from 10 to 18. And then you start at 19 plus 8, 27. So you go from 19 to 27. And then you start at 28 plus 8, that equals to 36. So you go from 38 to 36. And then you start at 37 plus 8, you have a 45. You go from 37 to 45. And then the last one, you start at 46, you plus 8, 52. So you go from 46 to 52. Do we have to make the numbers this big? The answer is no, that is really not necessary. But which one is right, which one is wrong? There is no right or wrong. There is appropriate and versus not necessary. To me, I will say this is good enough. This method is good enough, subtracting 1. But this is a question that a student asked me in the past. Hey, you say both are correct. So if the class is a little bit off, that might affect the number in the rest of the columns. Which one should I use on the test? Here is how I answer that question. Which one should you use on the test? On the test, I will just prepare the class for you. So on the test, the first column, I will type numbers into the first column. So you don't need to determine this by yourself. I do that for you. You start at the class boundary. So in that way, everybody is happy. You don't need to argue which one should I use. I give you the class. You start at the boundary. So everybody is happy in that case. All right? Now, I am going to fill in this table. I prefer to make the table bigger. So how about this? Let me do some magic. So because I am using this loadability. So I am going to box this and then shrink that a little bit. So I'm going to box that. Can I shrink this thing? Yep, I can shrink this thing. I can make this extremely small because we don't really need it now. Okay, let's shrink this too. Let's make this really, really small. We put that on the side, so we don't need that anymore. So now I can Make the table bigger. Okay, good. Now let's fill in the table. So the first column is a class, right? So we already decide the class. This is 1 to 8, and then 9 to 16, 17 to 24, and then 25 to 32, 33 to 40, and then 41 to 48. Now, there is a 1 unit gap, right, between each class. From let's erase the 2. That looks like 1 plus 0, 8. 1 to 8. So there is a 1 unit gap between the 8 and the 9. How do you minimize the 1 unit gap? So here is a picture. So let's say I have a number line. I go from 0 to 1. How do you, and I want to fit two, I want to divide this into two equal width, two equal segments, two equal pieces. How do you do it? You cut that right in the middle, right, which is 0.5. So the way you do this is you go from 0 to 0.5 and 1 to 0.5. This is a 1 unit gap, right? So 1 unit gap, the length is 1. The only way to cut this into two equal pieces is you make a cut at 0.5. So that's why for the 8, I have to do 8. So as long as you do 8 plus 0.5, that equals to 8.5. 9 minus 0.5, that equals to 8.5. So the gap between the first class and the second class is gone. All right, so for the class boundary, this is what you have to do. Take the lower limit, which is 1. 1 minus 0.5 equals to 0.5. And then take the upper limit, 8. 8 plus 0.5 equals to 8.5. And then 9 minus 0.5, 16 plus 0.5. Can I make this even bigger? Because that must be big enough. That equals to 16.5. And then the rest, 17 minus 0.5, 16.5. 24 minus 0.5, 24 plus 0.5. And then 25 minus 0.5, 32 plus 0.5. 33 minus 0.5, 40 plus 0.5. 41 minus 0.5, and then 48 plus 0.5. So now you can see that between every two classes, there are no more 1 unit gaps, right? Because class 1 and class 2, they both touching each other at 8.5. Class 2 and class 3, they are touching each other at 16.5. Class 3 and class 4, they are touching each other at 24.5. Okay? So the midpoint. So from 0 to 1, how do you find the middle between 0 and 1? So you simply take 0 plus 1 divided by 2, right? So that equals to 0.5. Same thing right here. So all you have to do is, let's switch to another color. You take 1 plus 8 divided by 2, you get 4.5. I am looking for the middle of this class. And then 9 plus 16 divided by 2 equals to 12.5. And then 14 plus 24 divided by 2 equals to 20.5. You do the plus first, all right? You add first, and then you divide. You don't divide first. You add first, and then you divide. 25 plus 32. 25 plus 32 divided by 2, that is 28.5. 33 plus 40 divided by 2, that is 36.5. And then 41 plus 48 divided by 2, that equals to 44.5. All right, so that is the midpoint. The midpoint is you add up two values and then divided by 2. Looks like you are taking the average of those two values. But remember, add first, get the sum first, and then cut the sum divided by 2. And then the next one is frequency. The frequency is asking, look at the data, how many numbers are between 1 and 8, including 1, including 8. So let's use another color to do that. So 1 to 8, so this is 1 all the way to 8, right? So, and then you count how many numbers are there. Count. I'm going to give you 5 seconds to do it. Count. Done, right? So 14. And then one of the ways to do the counting is using a tally mark. So what is a tally mark? Tally mark is a very old school way to count things. So as you go from 1, 2, 3, 1, 2, 2, 3, 3, 4, right? You go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that is a tally mark. All right. So when you count the sum, all right, I see 5 copies of that. So that is a total of 15. 5 plus 5 plus 5. Do you have to use tally mark? You don't really need to. We can count this very easily. But in some problems, they shuffle up the numbers. The numbers, they are not in ascending order. They shuffle up the numbers. Then you might want to use tally mark to help you because you don't want to miscount. You don't want to double count. And then the next one is 9 to 16. So we have 9. And then we go all the way to 16, right? So how many numbers are there? The answer is 21. And then 17 to 24, so 17. And then all the way to 24, there are 11 numbers. And then 25 to 32, so 25 and then all the way to 32, no 32, then we have 6. And then 33 to 40, so 33 to 40, we have a 4, and then the last one is also a 4. Remember, they gave you 16 numbers, so if you add up all 6 frequency, the total must be equals to 60. If the total is not 60, then you have a trouble. That means one of the frequencies is wrong, or maybe 2 of the frequencies are incorrect. You don't know which one is wrong, so the consequence is you have to go back to do this all over again. All right. So when you do this at home, in doing your online homework or solving a problem from a book, most of the time, 99% of the time, they shuffle up the data. Then you have to count very, very carefully. No double count, no miscount. And then the relative frequency. In math, the relative means they want you to compare every individual. They want you to, this is the correct way to say this. They want you to draw a ratio between each individual frequency and the total. That means you have to do a division or a fraction. So you take 14 and then you divide by the total. Do you need to put this in decimal? No. Just leave it like that. Do not simplify. Do not reduce the fraction. No decimal. Just do it like this. But if the book wants you to put this in decimal, then you have to follow direction. In my personal perspective, I prefer to just leave it like this because this exercise is not about reducing fraction. 21 over 60, 11 over 60, 6 over 60, 4 over 60, and 4 over 60. And then cumulative. What is cumulative? Cumulative means addition, adding things up. Put one on top of each other. So first, we start at 14. Change color for this. So first, we start at 14 because the first frequency is 14. And then you add the 14 to the 21. 14 plus 21, that is equals to 35. And then you add the 35 to 11, you get a 46. You add the 46 to 6, you get a 52. Add the 52 to 4, you have a 56. Add the 56 to 4, you have a 60. So this 60 and this 60, they match. And then I miss a grid, the sum of the relative frequency. So this is like adding fractions. You already have a common denominator. That's why I asked you do not simplify the fraction. So the sum must be 60 over 60, which is equals to 1. So that is the table. Now, tell me, which class has the highest frequency? Which class? This one, right? So this one is the highest, and then these two are the lowest. All right, so this is the frequency table. So I just organize this data set into this table. So what is the benefit of doing this? Now, if I ask you a question, hey, most of the people travel how many miles to work every day? And then you look at this table, look at the highest frequency. You say, okay, 21 people traveled around 9 to 16 miles to work every day. And then also you can see that most of the people, they are concentrated in the first 3 classes, right? 14, 21, and 11. And then you can say, all right, looks like in this area, most people travel 1 to 25 1 to 24 miles to work, because the highest frequency, they are concentrated in those three classes. So most people travel 1 to 24 miles to work. So I can make statements very easily looking at this table, because if you go back to the data, especially when the numbers are shuffled up, it is hard to make any observation. That's why you need this table to help you. Other than that, I can graph this table. So because if you already take notes, this is already on your notebook, so that's fine. If you are not taking any notes at this point, can you take a screenshot of this? Because I will be using this table to make histogram. I'm going to graph this table. So take a screenshot of this. Done. Okay, I am going to make 4 histogram. So the first one that I would like to do is I would like to use class boundaries and frequency. Let's switch color. Red is too dark. So boundaries and frequency. So the histogram looks like this. First, you have to prepare a vertical axis, and then you have to prepare a horizontal axis. 6 classes, right? I think we need we will need a longer horizontal axis, because I don't want to make the histogram too small. And then you have to label the horizontal and the vertical axis. So since the numbers are in miles, then this is in miles, and then this one is frequency, the vertical axis. So you have 6 classes, right? So first we use the boundaries. So you take a screenshot or notes, right? So we start at 0.5 to 8.5, and then using the same 8.5, we go to 16.5 and then 24.5. I am taking these numbers straight from the second column. 24.5 to 32.5, 32.5 to 40.5, and then to 48.5. Now, the height is 14, right? So the first one is not the highest, it's the second highest. So I am not going to scale my vertical axis. I will just draw this. I want to make this straight. Oh, come on. How about this? 14, and then the next one is 21. So 21 is the tallest bar, 21, and then 11, shorter than 14, and then a 6, and then a 4, and then a 4. So I just sketch a histogram. So the benefit of putting numbers on top of each bar is that you don't have to scale the vertical axis. I hate scaling those vertical axes because it's a sketch, right? So as long as the scale is reasonable, you will be okay. So other than this, I can make a midpoint and frequency. So let's do the next one. Midpoint. Using midpoint and frequency. All right, I have to scroll down. So you draw vertical axis, and then you draw a horizontal axis. So this is in miles, and then this is midpoint and yes, frequency. All right, how many midpoints do we have? We have 6, right? So 1, 2, 3, 4, 5, 6. The first bar is 14, so make sure this mark is right in the center of the bar. So that is a 14. This is 4.5, 12.5, 20.5, 28.5, 36.5, and 44.5. The next one is the tallest bar. Make sure the midpoint is the mark. This mark is right in the middle. So 21, and then you have 11. 11, and then you have a 6. It's off the center. 4, and a 4. All right. So what is the benefit of doing a histogram? What is the benefit of graphing the frequency table? The benefit is Now, with a histogram, you can see the tallest bar are in the first three classes, right? You don't even need to compare using numbers. You can use your eyes, use your common sense. I can see the tallest bar, they are right there, right? So that means most people travel 4.5 to 20.5 miles to work in that area. So I can see it, I can use my common sense to determine the tallest bar immediately. So I don't need to look at the data, I don't need to look at the table. Because the height of the bar tells me which class has the highest number of people. So these are the first two frequency. We can do two more. Instead of using frequency, we can use relative frequency. So let's switch color for that. So the next one, I would like to use boundary and relative frequency. All right, we do a horizontal axis, a vertical axis, and this one is a horizontal axis. So this is still miles. Make sure you label your numbers. Without these miles, I have no idea what this number represents. 44.5 what? Gallons, meters, miles, or what? I don't know. So this is a stats class, not an algebra class, not X and Y. Every number has a label. So it's miles. If that is dollars, then you use dollars. And then this is relative frequency. So that means they are all in fractions. So the boundaries, we have 0.5, 5 to 8.5, 16.5, 24.5, and then 32.5, and then 40.5, and then 48.5. Oh, okay. Sometimes the graph looks like this. When you look up for a histogram on a textbook, they will have a broken axis like this. This is called broken axis. Broken axis means sometimes, let's say this number starts at 80. So they want to skip the space between 0 and 80. So they use a broken axis. That means I don't care those space. Use a broken axis to skip those space for me. Relative frequency. So the first one is 14 over 60. So 14 over 60. This is 14 over 60. And then a 21. Just put a number on top of that. And then 11. And then 6. And then 4. All right, so that's it. This is using boundaries and relative frequency. So if you take a quick comparison on these two, notice that the shape never changed, right? The shape never changed. The only thing that is changing is this word and the fractions. Now, in this problem, I said that this is a frequency distribution, right? Distribution. This is a huge word in statistics. What is distribution? Now, distribution, just picture this in your mind. You have 60 numbers, right? So you have 60 numbers on your paper. Now, close your eye, listen to me, just picture this in your mind. You use your hand, grab those 6 numbers, all right? So now you have 60 numbers on your hand. Ready? And then you toss those 60 numbers, you throw those 60 numbers onto a XY axis, onto a blank histogram. Imagine that you only have a horizontal axis, y-axis, with no bars, no marks. One horizontal axis, one vertical axis. You have 60 numbers on your hand. Now, you toss those 60 numbers onto this blank picture, and the way they spread out looks like this. Now, open your eyes. Look at your screen. Do you see 3 tall bars followed by 3 short bars? This is how the 60 numbers spread out. You grab them, toss them into a blank picture, and you see how they spread out. So the way they spread out, the style they spread out is called distribution. Distribution basically describes how things spread out. All right, so that is distribution. I can see the distribution on my frequency, on my histogram. In a table, you can't really see it. If the table is really, really long, it's hard to see it. But if you graph the table, now you can see it pretty easily. Let's do the last one. So the last one is using midpoint and relative frequency. That is my favorite histogram. So the last one. I would like to use relative frequency. And then this, I will just use midpoint, but the label is still mild. So we have 6 classes, 6 marks. So this one is a 4.5. I got this from column 3 in the frequency table. 20.5, 28.5, and then 36.5, 44.5. So the first one right in the middle. So this is a 14. And then we have a 21, and then we have a 11. Let's fill in the blank. 14, 21, 11, and then a 6, and then a 4, and then a 4. All right, so this represents the distribution of the data, how the data distribute. Well, most of the people, they are concentrated in this area, so that means most people travel 4.5 to 20.5 miles to work every day. All right, so that will be the end of this video. If you think my video is helpful, please click the like, subscribe, share this video out for me if you have friends taking a stats class too. All right, I see you all in the next one.